In this video, we will be solving this question which says, sketch the level curves for the following functions at height specified by k. Your first part is your fxy is y cube minus x square at the height k is equal to 0. And your second part is gxy is equal to y minus ln x at the height k is equal to 0.2. So let's quickly learn what do you actually mean by level curves. The level curve of a function fxy are the curves of the equation fxy is equal to k where k is a constant. These curves show where the graph of f has height k for different values of k, and sometimes they are also called contour maps. Now our first function is fxy is equal to y cube minus x square and you have k is equal to 0. Now according to this concept, the equation of the level curve is this, that is fxy is equal to k. So you have y cube minus x square is equal to 0 as k is 0 in this particular case, which gives you x square is equal to y cube. Let's call this as equation number 1. Now, when your x is equal to 0, then your y is also 0. This means 0, 0 satisfies this. Also, you can note that y is always greater than or equal to 0 because y cube is equal to x square and x square is always positive. So, essentially your y cube is equal to a positive number or a 0. Thus, you get that y is always greater than or equal to 0. Now, differentiating this with respect to x, that will give me 2x is equal to 3y square dy by dx, or your dy by dx is equal to 2x by 3y square. Now note that at 0, 0, your dy by dx does not exist. So here your dy by dx does not exist. Now what happens in this range? When your all x's are positive, your dy by dx is greater than or equal to 0. So this means your function is increasing here, and when your x is less than 0, your dy by dx is less than equal to 0, which means for this particular range your function is decreasing. Now after finding the increase and decrease, let's find the curvature, and for that we have to find the double derivative, which means we have to differentiate dy by dx with respect to x. That will give me double derivative of y with respect to x as 2 divided by 3y square, as your dy by dx was 2x divided by 3y square. So differentiating this with respect to x, I will get 2 divided by 3y square plus 2x divided by 3 minus 2 multiplied by y to the power minus 3 dy by dx. Now we know that dy by dx is 2x divided by 3y square. So making the substitution and doing all the simplifications, I will get that the double derivative is 2 divided by 3y square minus 8x square divided by 9y to the power 5. Now we know that y cube is equal to x square, which means that y is equal to x to the power 2 divided by 3. Now it could be positive or negative, but we already know that y is always greater than or equal to 0. That's why we have eliminated the case scenario where y could be equal to minus of x square to the power 3. Now with this information, let's make the substitution and bring the derivative of y with respect to x solely in terms of x. Now making the substitution, I will get that the double derivative of y with respect to x is 2 divided by 3 x to the power 4 divided by 3 minus 8x square divided by 9 x to the power 2 divided by 3 to the power 5. Now in this scenario, powers will get multiplied, which will give me 2 divided by 3 x to the power 4 divided by 3 minus 8x square divided by 9 x to the power 10 divided by 3. Now again this x square can be brought to the denominator. That will give me this. Now after performing the calculation, I will get that your double derivative is nothing but 2 divided by 3 x to the power 4 divided by 3 minus 8 divided by 9 x to the power 4 divided by 3, and after taking the LCM, I will get that the double derivative is equal to minus 2 divided by 9 x to the power 4 divided by 3. Now note that this is always positive, this is positive, but this is negative, thus your double derivative is negative for all x's. Now let's summarize. For x greater than 0, your dy by dx is greater than or equal to 0 and your double derivative is less than 0, which means you have a concave down, which will look like this. And for x less than equal to 0, first order derivative is less than 0 and your second order derivative is also less than 0. So this would be this shape. Also you had the function that is x square is equal to y cube. This function is symmetric along the y-axis. Thus our graph will be this. So this is not your part of the graph. This and this is your graph, or I can say level curve. I have drawn some quick hacks or quick notes for you because sometimes it happens in the exam you do not know or you do not recall how your function will go. But if you have a rough idea, that makes things easier, because if it happens that you're short on time but you know these quick notes, then you will be just quickly draw the graph and have rough estimation that how will my graph look like, then you will be able to gain some points. And also these quick hacks always help you in verifying whether your solution is correct or not. Now note that when your first order derivative is less than 0, then you all know that the function is decreasing. This means your tangent will be downward sloping, which is like this. Now what happens when your double derivative is negative and what happens when your double derivative is positive with this particular scenario? When your double derivative is negative, your curve will always lie below the tangent, and when your double derivative is positive, your curve will always lie above the tangent. Now again, when your first order derivative is positive, then your function is increasing, that means your tangent will be upward sloping like this. Again, when your double derivative is negative, your function will be like this, that is, it will lie below the tangent first, but when your double derivative is positive, it will lie above the tangent. Now let's move on to the second part where your gxy is y minus ln x and your k is 0.2. Now by the definition, your level curve will have this equation, which means y minus ln x is equal to 0.2 or y is equal to 0.2 plus ln x. Now this is the case of shifting. Again, I will deal all the possible cases of shifting at the end of the solution just for your references, but let's first solve this question. That is, let's first sketch y is equal to ln x. So again, I will be first differentiating it with respect to x, that is dy by dx, which is equal to 1 divided by x. Now also note that the domain of ln x is 0 to infinity and your range is r for entire real numbers. Now if this is the domain, which means your x can only take these values, thus your x will always be positive, and if that is the case, then your dy by dx will also be always positive. When your x is positive, your dy by dx is increasing, which will be like this. Now let's differentiate it with respect to x. That will give me minus 1 divided by x square, which is less than 0. Thus, if you remember some quick tips I gave you in the previous part, that is, your first derivative is positive, which means your tangent would be facing upwards, but your second derivative is negative. That means it will lie below the tangent. Thus your graph will roughly look like this. Also, as you see that as x tends to 0, your ln x tends to minus infinity. So this is your graph for y is equal to ln x. But in our case, when k is equal to 0.2, your y is equal to ln x plus 0.2. This was your actual graph. Thus the graph shifts above by 0.2 units. How do I know this? Just be there with me and I will tell you all about shifting in just 2 or 3 minutes. But here again the domain will be same, because we are not altering anything with the x. All we are altering is with the range. That is, we are just adding 0.2 to your y value, but we are not doing any alterations with your x. Thus, your domain will remain the same. Be very particular about this point. Your graph shifts above by 0.2 units. This was your graph of y is equal to ln x, and it will shift above by 0.2 units. That is, this solid graph is now your final graph. That is, y is equal to ln x plus 0.2. Now let's learn about the shifting. I know at very first glance it looks very ugly, but be there with me. I'll explain you everything in much detail. Now your first case scenario is when your function is transformed to function plus minus a for all a to be positive. That is, your function fx changes from fx to fx plus a. This will shift the given graph of fx upwards through a units. So if this was your fx, that is the solid wave, then your fx plus a will be shifted upwards by a units. So you see a shift here by a units, and this is your graph for fx plus a. Now again, what happens when fx changes from fx to fx minus a? Then there is a shift in the given graph of fx downwards through a units, which is this. So this solid line shift downwards by a unit. Now what happens when your fx transforms to fx minus a? That is when your a is positive. This means there's a shift in the graph through a units towards the right. So if it is minus a, I will shift the graph towards the right by a unit. So this solid line is my fx. By shifting it by a units to the right, I will get fx minus a. Now what happens when fx transforms from fx to fx plus a? Again your a is positive. Then there is a shift towards the left. So this is your fx plus a graph. This. Now note here that here domain changes. Domain changes because here you are changing your input value. Earlier it was only x. Now it is x minus a. Now it is x plus a. So your input value changes. So here your domain changes. But here it was fx, fx, fx. Your x value remains as it is. Your input value remains as it is. Thus your domain does not change. No change. Remember these small points.